Hello, math fans. Going to give a quick intro to the project of half of a sphere. If you're interested in these other projects, I believe these two already have some videos to go with them, but this is new. So this is just in doing 3D prints with a project last term. We realized that there's a lot of what I like about this question is it's something that anybody can do. So I'm proposing that students find other ways to cut a sphere in half or dissect it in half. So I give a couple examples. If you're going to drill a hole directly through the center of a sphere, how could you do that so that exactly half of the volume remains if you cut it with a cone? Some interesting ones are these planes. And so can you cut it with two planes, two equally spaced vertical planes, so that the volume of the blue there in the middle is equal to the volume of the green on either side? A more interesting question is if you cut it up with 6 planes, all of them at the same distance from the origin. So x equals a, x equals minus a, y equals a, y equals minus a. How would you cut it so that half of the sphere remains? And it appears that's not an easy question. Maybe I'm missing something. But where would that be? Or what if you had 2 circles of the same radius? How close would you have to bring this other one in so that the volume of revolution would be half? An interesting thing is if you could make a model of that where if you took this circle all the way around, it's like a donut around a circle. I feel like all of these would be a Calculus 1 student could do. They might need an integrator if the integral is not that easy to do, but there are so many interesting shapes, and so I would like you to experiment, come up with your own questions, and just answer those. And I feel like almost every student could come up with their own, and we could print and have a gallery of many dissections of a sphere. And some of them lead to some interesting questions I've noticed. So this is just a small little nugget that I think could be interesting. Anyways, so come up with your ideas. I'm really interested to know what the volume of that shape is. So how do you with 6 planes, how would you cut that up? I have not answered these yet, some of these. I'm intentionally doing it this way. I want to allow students to answer and figure out what are some interesting questions. All right.